Sorry, they're online. I didn't realize I was muted. All right, so we starting trigs. And once we start talking about trigs, we have three functions: sine, cos, and tan. Right? And they all link to a right angle triangle, right? Sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan is opposite over adjacent. Okay? So these are the first set of rules that we need to know, right? And we want to be able to apply them. All right. Just a quick example in using these rules. We're not seeing the button up there, right? So the first thing I want you to remember in doing these rules is this, right? Let's say I gave you this. Hopefully you all can do it mentally, right? Here's theta. If here is 5 and here is 4, how much is it? Okay, forget the mental part. Work it out from us. Work it out from us. And then let's see if we can find sine, cos, tan. Oh yeah, work it out. Use Pythagoras theorem and work it out. Yes. Work it out from a quick. Sine, cos, and tan. Work out the value and then write down what the sine, cos, and tan. That's all. Why can't it not be 50? Right, so if you work it out using Pythagoras theorem, you'll get here is 3. Yeah. So then we've got everything here. Sine is what? 4 and 5. Cos is 3 and 5. Tan is 4 and 3. Right? 4 and 3. Everybody okay with that? Any questions online? How about those values? So I gave you a right angle triangle. We found the adjacent and then we can work out everything. Sine, cos, and tan. That's okay? Any questions online? Shannon, Alejandra, any questions? Are you okay there? Okay, nice. So what would happen here, Shana? Suppose I study Shana suppose I gave you this. I told you that cos theta is equal to 4 and 5. And I would like you to find sine theta and tan theta. What you'll do? What you'll do to work out this? The hint is of course in. Anybody? Yeah, construct the triangle. Right? Yes. And then from the triangle, we know what is, and we know what is hypotenuse. So we know that adjacent is 4, hypotenuse is 5. And we can easily find opposite. And we know the answer, right? So sine is what? Sine is 3 over 5. Tan is 3 over. Are you okay there? Easy. Copy it down. That's the intro into it, right? Of course, it will be a little more challenging. Copy down, try number 3. Copy down and try number 3. Right, online you can message your answers, right? Right, what you got for sine and what you got for tan. Let's see what we have. We have opposite and we have hypotenuse. Okay. So we come back here to a right angle triangle. Here's theta. We have opposite, hypotenuse. Right? And I want to find an adjacent. So you use it. So root 3 squared, 2 squared plus, let's call it x squared. Root 3 squared is 3, 2 squared is 4, plus x squared. Correct? Oh, sorry. See what happening here? I'll get a minus number. Right? Opposite is root 3. Adjacent is 2. Sorry. So hypotenuse is 2, adjacent is. So this is 4 is equal to 3 plus x squared. So x squared is equal to 4 minus 3. X squared is 1. X is the square root of 1. So x is 1. So this value here is 1. Okay? So mirror. So I use Pythagoras theorem with itself, right? And now they want what? Cosine theta is equal to opposite, sorry, adjacent over hypotenuse. And tan theta is opposite over adjacent. Okay. Let's go again. Right, online, did I get any answers? I only get one answer from Barrage, which was correct. Very good, Barrage. Christian on the message answers, right? Christian and Darian and Ariana and Katrina. Don't forget the message answer. Try number 4. Please catch a triangular. Okay, now? Take your time, get a triangular. Good job. Yeah, I can start back after the lesson. Thanks for looking back. Right now, Tanya answers. Christian looking good there. Katrina, nice. Malini, nice. Jamian, good. Sahara, good. Alejandra, nice. Excuse everybody else, I didn't get answers. Darian, Sahara, Selena, everybody else. But Shannon, will hurry up, please. Sorry, yes, Sahara, I got yours. All right, let's see. So we set that up the right angle triangle. Right here is theta. It doesn't matter where it's theta, right? We have opposite and we have adjacent. When you work it out, hypotenuse is 30. Tan theta is equal to, sorry, cos theta is equal to adjacent over hypotenuse, and sine theta is opposite over hypotenuse. That's okay. Last one like this. What you will notice here, and I'll tell you in a little while, is that all these angles here are acute. So theta is acute. What does that mean again? Between and 90, right? And then I make it a little more complicated when it's obtuse. Okay, in a little while. Now, yeah, one more easy one. One more easy question here. Once I give you, you sure? Once I need to put them in. Right, try this here. If tan theta is 1, I would like you to find cosine theta and sine theta. Go ahead, have fun. Last one then. Last one like this, and then we're gonna learn something else about time, cost, and time. Yeah. Right, next thing, oh yeah, but try to figure this one out. But yeah, do just figure out what values you're going to put on the triangle. Huh? It could be anything you want, once you get one. Right? And I like what Krasna. What was his first name? Kalia. Okay, I wouldn't remember that. I'll call it Krasna, right? I like what Krasna did. Instead of trying to figure out what will give you one, she has put 1 and 1. You can put 5 and 5, 3 and 3, 2 and 2, it don't matter. Once you get 10 to be 1. Okay? And they will all simplify to get rid of the same thing. Right, so when you work this out, you'll get root 2 here. Yeah. So cosine theta is equal to adjacent on root 2. Sine theta is equal to opposite on root. Right, good job, Christian. Nice, good job there, Olivia. All right, good job, Christian. Barrage, very good. Right, well, Darian, we have to use the exact value. So the only problem is what? Like sharp calculators will not give you this, right? As it does the only problem. Casio, on the other hand, will give you this exact value. All right. And you sort of reach back for class finish. Okay, nice. So make a little note here that all these angles here are acute, right? Just make a note of it that all the angles here are acute. We are going to look at the problem now when the angle becomes obtuse. So we're going to look at the problem now when the angle becomes obtuse. Right? So make a subheading when theta is obtuse. Subheading when theta is obtuse. Okay? Right? Obtuse means what? Obtuse means between 90 and 180. Nice. So here's what we're going to do. Right? I am going to take a circle and I'm going to split the circle up into 4. I'm going to split the circle into 4 quadrants. First quadrant here is between 0 degrees and 90 degrees. Second quadrant here is between 90 degrees and 180. Third quadrant here is between 180 and 270. That's not. I had it further and hold here. Yeah. You know it by the class. Yeah. All right. So yeah, we'll talk them after. All right. Right, 270, 360. All right. So if I ask you now to take a circle and split everything up into 4, this is what you will do. You'll put them into 4 quadrants, right? Your first quadrant is 0 to 90. That is where everything is acute, right? 90 to 180, where everything is obtuse. What is it called here again?
Another one of them is reflex.
Reflexor. Reflexes here or here? All here is reflex.
Yeah.
All there is reflex. Right. So you have obtuse, acute, and reflex. Anyway, that's so important. What's important is we need to understand how sine, cos, and tan behave between 0 and 90 and between 90 and 180. All right, thank you. You take a number quickly. Huh? Oh, you're lying. What? What is this? Yeah, keep this. All right. All right. So here's what we need. We need to understand how sine, cos, and tan behaves, right? Inside here and inside here. Right? So let's pick an angle between 0 and 90. Pick an angle between 0 and 90. 45. Okay. We'll take calculator and find sine 45, cos 45, tan 45. Please make sure your calculator is in degrees. We're not working in radians as yet. I'll do radians next week. Right, online, you'll hear me still, because the rain starting to fall a little hard. Shannon, you'll hear in there? Yeah, okay. Right, so work out those values there for me. Sine 45, cos 45, tan 45. What you got here? Huh? If you have a star, you'll say it. Right, 102. Okay, sorry. 1 over. Tan is how much? Okay, what you all recognize but all the values? All the values are positive. All the values are positive. So it means that sine theta is positive here. Right? So it means that all the values between 0 and 90 are positive. Are you okay with that, Samira? So pick a next value. Pick a next value between 0 and 90 and find the same thing. Right? Pick a next value like 30. Where you calculate that? Right? Pick a next value between 0 and 90 and find cos, sine, and tan. And you will recognize that right online. So what we learn here is that every sine, cos, and tan value is positive between 0 and 90. Okay? So once it's acute, everything positive. Now pick a value between 90 and 180. What y'all pick? 100, 120. Look it out, some what you recognize. Find sine 120, cos 120, tan 120. Tell me what you observe. Oh, wait, pure as a double. Right, so work out sine, cos, and tan. Tell me what you recognize. Work out sine, cos, and tan. Tell me what you recognize, right? What do you recognize, Jacob? Alright, can you hurry up, please? Right, good job, Richard. Right, we'll show you this graphically, right? Probably number it there. Right, Adele found sine to be positive. She got here to be positive. I think it's positive root 3 and 2. Yeah. And she got here to be negative. Okay. And here's what? Just negative root 3. So you recognize here that sine positive, cos negative, tan negative. Okay? It's on, we'll come and learn all these rules here. For now, we just, in fact, you're gonna do all this one time. Let's do all this one time. Tell me what is sine, cos, tan here. Tell me what is sine, cos, tan. Use any value you want and tell me what you recognize here about sine, cos, and tan. Work out what is sine, cos, and tan and all the other quadrants. Pick any value you want. And if you know it's already, just plug it in, right? Right, out here, the mirror, what you got in quadrant 3. Last one, quick, last one. Sine is what? Pluses and tan is negative. Okay, nice job, Katrina. Okay, so those are the signs, right? We have to learn the sign convention, right? The reason for that is this. Let's change our question slightly. So we're going back to what we were doing earlier, right? So F theta is obtuse. If theta is obtuse and sine theta is equal to 3/5, find cos theta and tan theta. Okay, find cos theta and tan theta. Right? What does obtuse mean? Obtuse means that the angle is in, right? Obtuse means that the angle, right, is in the second quadrant. So it means that it's in here, right? So it means that whatever we got for the sine value, that has to stay positive. Whatever we get for the cos value, that has to stay negative, and here's also negative. Okay, so what we do, we're doing the same thing, right? We don't have to overcomplicate it. We're doing the same thing. We know that sine theta is equal to opposite over hypotenuse. If we work out, use Pythagoras theorem and find adjacent. Okay, and we know that cos is what? Cos is adjacent over hypotenuse. But what do we do? Include a negative sign because cos is negative. Are you okay with that? And tan is what? Negative as well. Negative 2. You're okay with that? So nothing changed except the sign, right? Why the sign changed? The sign changed because the angle is now obtuse. So you have to look out and see if the angle is obtuse or if the angle is acute. Okay? So you do it like normal and put in the signs. There's a next way to do it, but I don't want to confuse you with those angles. All right, last one. Yep. I got you. Pete. Right, online, please remember to message your answers. Alright, nice Sahara. Let me see who in Selma anything. Most people messaging except for Shannon. All right, so quick little graph here. Diagram. Theta, we have opposite and we have adjacent and we can find tan. Sorry, we can get hypotenuse 10. So sine is equal to we obtuse, so that's negative. That'll be adjacent over this, so that's 8 on 10. And sine is 6 on 8. Okay, correct? Alright. I was making sure. 6 on 10. And the sine is positive. Okay. All right. So we have some more rules that we'll use this in later on, but not right now. All right. All right. So nice. So we have a little introduction and the tricks. Now that we kind of seeing how sine, cos, and tan behaving between 0 and 360, we're going to do a sketch. We're going to do a sketch for each one of them. All right. So head up graphs for sine, cos, and tan. Head up graphs for sine, cos, and tan. Right, graphs for sine, cos, and tan. There are some values that we should learn, right? So I'll give it them here. All right, so see these values here 1, 2, 3, 4, 5. These values we should know by just watching them. You shouldn't have to go to a calculator later on. These are values that you should know for sine, cos, and tan. Right? And once you know those values, it gives you an idea of how the shape of the graph will look. So let's do my pick paper in degrees, work out all these splits, and then we're going to do a quick sketch. Right? We're going to do a quick sketch of the sine graph. Right? We had a graph with sine, cos, and tan. So work out those values and then we're going to try to plot it up. You have a calculator, you want to figure it out. If you turn your head from the side, oh. And then we're going to try to plot it, right? Right, here is 90. Here is 180, 270, 36. Right? What was the largest value that you all got for sine? 1, right? There's no value bigger than 1. And the smallest value, -1. There's nothing smaller than -1. All right, and we're going to try to plot them together now. Let's plot them up and see what we get. Here's how much? Yes. 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 So you're plotting 0 here, 1 here, 0 here, -1, 0. So I'm behaving. They go enough. On the back down. That's a sine graph. Right? Sine graph looks like that. Good. That's what your sine graph will look like. Sketch up. So that is your sine graph. Just technically done now. So what we learn here about the graph? What we learn about sine theta between 0 and 180? All the values are what? Positive. See, that's mirror. All the values positive. Sine positive between 0 and 180. So the same thing we saw here, we see it here. Right? And all the values between 180 and 360 are what? Negative. You're seeing that? So all the sine values here are positive. All the cos values, sorry, all the sine values here are negative. Are you okay with that? All right. So let's see if we can do a similar thing and sketch this cos graph from a similar value. Kind of be a little bit harder. Mightn't be able to get tan from there. Right, so try and see if you can in a similar way plot the cos graph. Oh yeah, try and look up cos 0, cos 90. Plug them up. Let's see what the shapes looks like. Can I get up? Let's see how it looks. All right, so if you check it out here, you will see that of course you have 1 and you have -1, right? Cos 0 is 1, cos 90 is 0, cos 180 is here, cos 270 is here, cos 360 is here. The graph is going to look something like that. All right, that's the cos graph. Again, what do we observe? Right, positive here, negative here, negative here, right? What do we observe about the cos graph? First, between 0 and 98, between 90 and 188, 180 and 278, 270 and 368. So your graph telling you the same thing you're seeing here. Okay? Right? Tan graph a little bit harder. So what you're saying? Go to your calculator. Go to your calculator and put in tan 90 and tell me what you're getting. Error. Right? One of the reasons that tan 90 does not exist. So it means that your graph cannot touch this line here. So it's gonna look something like this. Right? Tan looks like that. Down here it's negative, so it looks like this. Here it's positive, so it come back up again. Here it's negative. So it's positive here, negative here, positive here, negative here. Right? These lines here, anybody know what it call these lines? Dotted lines. Huh? Wait, is somebody saying it there? What is it called them? What? Anybody knows online? Online? Why is call these two dotted lines here? Asymptotes, right? Those are lines that the function will come close to but never touch, right? Those two lines are asymptotes. Okay, so tan 90 and tan 270 are the only two tan values that go well in this part of the graph that doesn't exist. You'll keep thinking with the shape here. Watch. So it's coming up here, coming close to this, but doesn't touch. It starts here and starts here. Draw it. Put here, draw it. Again, you will see positive, negative, positive, negative. Same thing you see in here. Positive, negative, positive, negative. Okay. So you take, remember those things, right? You'll have to do the shape of the graphs, right? Any questions online? So how come it does have a curve for the tan graph? What do you mean, Alejandro? Like why it's shaped like this? Yeah. Why it's shaped like this? Yeah, or the reason it's shaped like this is that if you were to plot all the values between here, right, and you plot it, this is the shape that you'll end up with. But the thing about this shape is that this curve, although it keep going higher and higher, it will never touch this line here. So the graph will kind of be discontinuous. It will stop here and then any value after 90 to start back. Right? And then when it reaches close to 270, same thing will happen. Right? Same thing will happen. It will stop and then start back again after this. So the shape of the graph when plotted has a kind of curved shape like this. Okay? Those dotted lines there are just imaginary lines to show you where the graph does not exist. So it's not continuous like this. It moves and it stops and it continues like. So there's a point where there is nothing. Right? That's right here. That answer your question? All right. Right, quickly, before we wrap up. What's the maximum value here, minimum value here, max min, max min? What's the maximum value here, Pete? Minimum value. Right? Malachi, what's the maximum value here? And the minimum value? -1. Based on what you're seeing here in the graph, what's the maximum value, Bradley? Yeah. So what I mean?
When it's up, I relate to be twice as
Infinity. That's why. So the maximum value is infinity, and the minimum value is negative infinity. Right? So it means that you could get any value per tan. You could find tan or anything, but we have a limit here. So sine and cos. All right. All right. Next day we will go on to solving trig functions, right? So you need to know your graphs, and then from here we'll move on to solve it. And then we'll focus on identity. See you next week.